Hello again. This is episode 2 in my little series to help newcomers to Jeti find their way around and get the system set up properly. So in the last episode, episode 1, we looked at the system configuration menu basically. Let's have a look further on. So we go into System. Next down in the system list is Servo and Range Test. In this, you would press the programming button, once of course you're bound up and everything switched on, to put the model into system into range test. And you can walk your relevant distance away and check your range. The numbers in here will tell you out of 9 how each receiver aerial is doing. So you can actually watch live how strongly the system is being received at the receiver while you're doing the range check. And typically, even at the sort of distance that Jeti recommends in range test, which is low power mode, I will get 7s, 8s, or even 9s out of 9s. And it will make a beeping noise when you're in range test mode, just warning you that something's going on. Press the button again to come out of it. Down here is a system where you can set servos to just cycle back and forwards at some slowish speed. Which can be useful just for testing a servo, but it's also decent in range test mode. Set a servo off cycling whilst you're walking away. Of course, you would have somebody with the model, restraining it perhaps, if needs be, if the engine's running for a range test, or at least just checking that the servos are working properly, not jittering, it hasn't gone into failsafe for a fraction of a second. And you could set a servo cycling backwards and forwards from the transmitter. So of course, if that servo stops or starts moving in a jerky fashion, the person watching the model could see that something's not right. Okay. View inputs. Now this is something that I would certainly recommend you do, even if you've just bought a new transmitter or a second-hand one, and this is to calibrate the system. What this screen is showing you is the proportional widgets, if you like, sticks, sliders, what have you, that you have. Here's the right hand one. The little circle, the gun sight thing, shows where the stick is. I'm going to push left aileron, right aileron, up elevator, down elevator. Notice that the numbers underneath correspond to the numbers beside the sticks. So stick proportional 1, P1 it's called for proportional 1, P2. On this side you got P3, and for me the throttle P4. And these show the rotary dials. Number 8, there's an 8 against a little rotary control on the transmitter. Number 7, there's one there. And 5 and 6, the side sliders on my transmitter. You move them like that. If you press the arrow, which is this button here, it goes to the next screen along, which shows the switches, and they correspond to the labels. Don't worry that the symbol here appears to be in the opposite direction to the physical switch. For instance, SA, my switch SA, it's showing it's a 3-position switch. There it moves around its 3 positions. The symbol appears to be going the opposite way to the switch. My switch is in the, what I would say, the down position. It's away from me. It looks here, it's up. I would say that the switch is in the up position. It looks like it's towards me. That looks down. Don't bother about that. In many cases, the way that the switch is physically oriented is determined by the layout inside the transmitter. For instance, in my transmitter, the switches for the DS, they have a little printed circuit board on the back, and it's not symmetrical at the back of the switch. It really sticks out at one end, thus forcing you, because of the edge of the case, to install the switch only one way around. And if that's the way around it goes, that's the way around it goes. So don't be concerned about that apparently moving the wrong way. Push the left button, go back to that screen, because here's very important, calibrate. So if you've got a second-hand transmitter you've just received, I would thoroughly recommend you calibrate it, because you don't know what the previous user has done, if they ever calibrated it, if during time it's drifted out of calibration. If you've got a new transmitter, well, why not do it anyway? It would have been calibrated, of course, when it was made, but you never know what has happened to knock it slightly out of calibration. I don't know what would, but There's no harm in doing it. So you press the calib button. It says, really calibrate? That button for no, that button for yes. Say yes. It says, move all the proportional controls a few times from one endpoint to another. Then put them at center and press calib again. So straightforward enough. I'll just rotate that stick around a few times. Rotate that stick around a few times. I do it a few times more. I'll move my side sliders. Blah, 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 that one. Move my rotary controls like that. Make sure you get to the end points. Very important you get to the end points so the system understand that the maximum and minimum values it got were the end points. If you don't get all the way there, it might think the end point was before you actually got there. Now, it says leave sticks at centered. I'm presuming it means leave all of them at centered, not just the sticks themselves, which is easy enough to do with the side sliders because they have a centered detent in them. So there's no mistaking when you got them there. But with the rotary controls, they don't. You're just going to have to look at the little indicator on them and take a guess at when you've got it properly centered. You could say, aha, I'll switch on center beep, but and then I'll know when I've got it centered. But it could be that, of course, center beep works on the center that you left it in calibration. So I've got them where I wanted. I'd press calibrate again, and that would be it done. I'm not going to press calibrate again because I've done it recently, and I can't see that the P7 and P8 are properly centered here because I've got the camera on a mount above them. So I'm just going to escape out. But as you say, press calib again, press calib, and that's it done. And you're all calibrated. Okay. Receiver output. This shows what's actually coming out of the sockets on the receiver. If I move the throttle, for example, you can see it going from minus 100% through 0 to plus 100%. If I move the aileron, you can see it moving there. Oh, yeah, minus 100. There is a little button here, which is meant to be 2 arrows going around in a circle. That's because there are actually 3 versions of this screen, and you can toggle through them by pressing this button. So you think to yourself, I want to check what's actually being sent to the servo. I can't remember which servo's which. Press the toggle button, and it actually tells you the name assigned to each channel. What it's telling you there is throttle 1, in the number in the brackets is channel 1. Aileron 1, channel 2. Elevator 1, channel 3. Rudder 1, channel 4. You're thinking, why is it calling them aileron 1, elevator 1? Because if, for instance, you have a 2 aileron model, the other aileron would be aileron 2, brackets, its channel number, and this kind of thing. And the same if you have multiple throttles, elevators, rudder, servos. Okay. Press the button again. Notice it's still reading in percentage. So press the button again. It gives you the actual number of milliseconds at the output. Or if you multiply by 1,000, you get the microseconds. So for instance, my channel 1, which is throttle down, minus 100% is 1 millisecond. Put it up to the maximum, it's 2 milliseconds. Notice that the default center for channels, like the aileron, elevator, rudder, etc., is 1.5 milliseconds, and they go up to 2 and down to 1. Press it again, and you're back to the first screen, the default screen. Interestingly, those numbers that it defaults to, which is from 1 millisecond to 2 milliseconds, is more than the default in a JR or a Futaba. For example, a JR at 100% travel went from 1.1 to 1.9 milliseconds, whereas this is going from 1 to 2 milliseconds. So if you've come from a JR transmitter and you've set up your Jeti, then you're going to be driving the servos a bit further than the JR did. In other words, you're going to get a bit more controlled travel. If you don't want to go adjusting the linkages in the aircraft to reduce the travel, if you're not happy with the increased travel, because of course you spent time getting your model set up and it may be that you've got mechanical limits to it, then you could turn the travels down to 80%, that's 80% in Jeti would equal the JR default, for example. System sound is where the pre-made functions that you cannot alter have a sound file assigned to them and maybe a value, and you can alter these. So when you switch it on, it plays this tding.wav. If you want to hear what it is, press the play button. So yeah, that's what we get when the system really starts up. The noise it makes when the receiver has bound and it's found one is that one. The low transmitter voltage plays this.
Warning, transmitter low battery.
That might be different to yours. I've made a lot of my own sound files and put them in here because I think they make more sense sometimes than the Jeti one, which might just be a beep. And you think, what the hell is that beep trying to tell me? Because there's lots of different beeps. Or it might just say, warning, low battery. I've got a battery in the transmitter. I've got 2 batteries feeding a central box in the plane. I've got a battery for the turbine. Which one is it? It makes much more sense to have specific warnings that tell you which battery is low. And here is the value, which I think was set by Jeti. Yeah. Down to the low signal.
Low aerial value, low aerial value.
Again, that's a custom one that I've done and installed because what was happening is that as it came, Jeti assigned the same voice file to low signal and low signal on the aerials and low signal quality. The signal at the aerials means how loudly the aerials are receiving the transmitter, and obviously as you get further away, the signal gets quieter and quieter. If it can't hear it anymore, or it gets down to a particularly low volume level, in this case 1, remember we talked about the signals being out of 9, 1 out of 9, it will warn me. Yours might have a much higher value, and it might get triggered sometimes when there's not really a problem. Low signal, the Q, is actually the percentage of the data packets in both directions that have worked. So you can end up with a low Q warning if just the telemetry is dropping out. But I thought the default Jeti one was just saying, warning, weak signal, which didn't tell me which one was going wrong. So I made custom ones that tell me the difference, and I reset the values here lower to suit me. If you're happy with the Jeti default values, go with that. I'm not suggesting that my values are any better than Jeti's. You might want to err on the side of caution and stick with the Jeti values. So now, if I'm getting a very weak signal at the receiver, I get this warning.
Low aerial value, low aerial value.
Whereas if I'm getting a nice strong signal, but it's badly corrupted because there's an awful lot of transmitters on, industrial Wi-Fi is running, shielding and blocking on the model due to carbon fiber or metal, I'll get this.
Low Q value, low Q value.
And I know that that's a very different thing to low weak signal. To me, the Q value matters much more. Signal lost. If it loses signal altogether, and this is the one you get when you switch the receiver off.
Signal lost.
Receiver reboot, nothing happens, but you would get a message up here. If you want, create a sound file or put any sound file in there. Range test. That's the noise it makes, and it keeps going whilst I'm in range test mode. If I wanted, I could create a custom voice file, put it in here, and then when I go into range test mode, instead of making that beep beep noise, it would say range test. Range test. Auto trim. There is a wonderful facility on Jeti called auto trim. It defaults to making a beeping noise when it's switched on, which doesn't really tell you anything because lots of things make beeping noises. So again, I made a custom voice file.
Auto trim.
And it will just keep saying that whilst I've got it on. Inactivity alarm. I think that's a standard Jeti one.
Inactivity alarm.
And you can set how long it takes from you doing nothing for the inactivity alarm to come on. It's saved me a few times. I've gone and sat down chatting with people at the pits, before lockdown and social isolation, of course. And after a few minutes, I start to hear floating from a distance away this little female voice going, inactivity alarm, inactivity alarm. I think, oh, I've left my transmitter switched on. So there you are. You can't change these ones. They are set by Jeti, but you can change what the output is and, if needs be, the value. Sound volume. There's various volumes in here. The beep volume, that's the beep. The vario volume, if you've got a variometer fitted, you can set a volume for that. I've actually set mine to work off the slider P5. So if I do that, you can see the vario volume up here going up and down, and you can see it going in the display there. Very handy when you're using an earpiece, or if you're in a pilot's box surrounded by other people, you can really turn it down or up. Playback volume, I believe, applies to voice files when you move switches, that kind of thing. Volume, I suspect, is an overall volume controller. Okay. USB, if you plug in a USB cable and plug it into a PC, for instance, to do backups or software updates, it will automatically say, you know, do you want to connect USB? But if you wanted separately to do it, you could go in here and set it. Okay. Installed modules doesn't really apply to the DS16 or the DS24. I think this more applies to the 12 and probably, I think, the 14, which come standard with less functionality than they're capable of, and you buy the additional capability or modules that you want. And it would tell you down here of which modules you've got of a tick or an X. The 16 comes fully loaded with 16's ability, so everything is ticked, and it's got the maximum number of channels, flight modes, etc. that it can have, because there simply isn't a choice with a 16. But if you've got a 12 or a 14, this will tell you what's been installed. So if you just bought one with extra modules installed, allegedly, from a shop or a second-hand one, you can check in here what's actually there. Info, I think that's the last one on this list, tells you what your transmitter is, the current version of the firmware that you've got installed, and you can check that against Jeti's website, or just plug the thing into Jeti Studio PC software and it'll check whether you've got the latest one installed. And it also tells me here I've got the Lua version of the Jeti 16 firmware installed. I can choose whether to have standard, which does not include Lua, or with Lua. Lua allows you to run little apps written by users. The state of the SD card, and it then tells you here the transmitter's primary module is bound to receiver number 437 blah 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 blah, and transmitter secondary module, it's not bound because this is a standard default mode. And then a whole load of computer gobbledygook. Okie doke. So that takes you down through the system menu.